Another numerical description data is a measure of spread. So measure of center is important, but measure of spread is also very important because you want to know how much variability there is in your data set. So spread can tell you, we can say what the mean temperature is of let's say a town, but the spread tells you how much variability there is in that town's temperature. So as an example, in Flagstaff, Arizona, the mean temperature in June and the mean temperature in August are about the same, but the variability is not as the same. So June can see really hot days and really cold days, whereas August pretty much has very similar days. So you have less variability in August than you do in June. And so you want a way of measuring that. One measure of that is what we call the range. The range isn't all that interesting and useful, but it is an important one to have. And all you do to find the range is you take your maximum data value, subtract your minimum. A better one is what we call the variance and standard deviation. So this is a better measure of spread or variability. The symbol for the population variance is sigma. And yes, I know we used sigma before. It looked a little different. This is lowercase sigma, the other one was capital sigma. So this is sigma, and the squares on there, I'll show you why in a little bit. The sample variance, we want to use the same kind of symbol for it. This is the Greek letter sigma. So since sigma starts with an S, we use S. So this is S squared. The standard deviation is where you take the square root of variance. So if I took the variance, the square root of sigma squared, I'd get sigma. So that's why we use sigma squared. And then the standard deviation for the sample is, again, you take a sigma, take the square root of S squared, which is S. This is the one we use an awful lot of. So usually when you deal with anything, you'll be dealing with the standard deviation from the sample. Again, that's weird looking O looking thing is called sigma. And it's a Greek letter, it's a lowercase. All right, so we want to talk about how do we calculate this. Really, the standard deviation is a measure of how far the data points are from the mean on average. So we're looking to see how far are those data values from the mean. So we're going to take each data value and subtract off the mean. These are what we call the deviations. So if you take the data value, subtract the mean, you find out how far away each data value is from the mean. Then we square each of those deviations. The reason for squaring them is because some are negative and some are positive. And if you don't square them, then when you add them together, you get 0 or approximately 0. So by squaring them, it gets rid of that negative sign, makes them all positive. And then we're going to add all the squared deviations together. And then you can divide not by n, but by n minus 1. This is known as the variance, which is at S squared or sigma squared. Then once you take the square root of that, you get the standard deviation, which is the S or the sigma. So let's actually do an example of showing you this whole process. So let's go back to our calculus test scores. We'll do the original one without the 20. So we'll have just these 9 data points. The mean from this was a 75%. If I wanted to find the range, I notice my maximum value is 92 and my minimum value is a 50. So my range is 92 minus 50 or 42. Problem with it is range doesn't tell you a whole lot of information because I can have several with the same range, but you don't know what happens in between those. So the easiest way to do this is not try to follow this process or what the formula says, but to actually make a table. So we'll put each of the x values, each of my data values in the first column. And then we're going to do them is subtract each of these values minus the mean. So 72 minus 75 is negative 3. 92 minus 75 is 17. 82 minus 75 is 7. 73 minus 75 is negative 2. 63 minus 75 is negative 12. 50 minus 75 is negative 25. 90 minus 75 is 15. 71 minus 75 is negative 4. And 82 minus 75 is 7. If I were to add this column up, add all these numbers together, I would get 0. Or approximately 0. Maybe not perfectly 0 if I had rounding. In this case, I have no rounding, so I'll get exactly 0. So that's where we have to square them all. Because otherwise, we have a 0 deviation. That doesn't help me. And so we'll square each one. When you square a number, remember it becomes positive. So we now have all these positive numbers, and we add them all together. And when I add all these numbers together, I get 1410. If I then take this number and divide by not 9, but 9 minus 1. So this is what the formula looks like. But again, I wouldn't actually try to use the formula. I would try to do it with a table. It's much easier that way. And so I'm going to take this total right here, it's adding up x minus x bar squared, and divide by 9 minus 1. Since there's 9 data values, 9 minus 1 is 8, so we're going to divide by 8. And that gives me 176.25. That is the variance. And that actually is the average distance from the mean, an average squared distance from the mean. Now what I'm going to do is I'm going to find the standard deviation by taking the square root of it. So here is the formula for the standard deviation, but again, just take the square root of this variance, take the square root of it, and you get 13.28%. So that means on average, this calculus test scores were 13.28 away from the mean. So that gives you kind of a measure of the standard deviation. If you have a really big standard deviation, so this number was huge, that means you have a much bigger spread, less consistent data. If I have a much smaller standard deviation of this, then that means my data values are really close because their average distance from the mean isn't very far. So it gives you an idea of how far they are. So the bigger it is, that means the more spread out your data is, less consistent. Smaller it is, it means the closer they are and the more consistent your data is. So in this case, we're looking at the fact that we're kind of a relatively large standard deviation. So that means their scores are not all around the same value, that they kind of spread out. And looking at it, you can kind of see they are kind of spread out. But this actually gives you a numerical number to say what it is. There are formulas for the population standard deviation and the population variance. They're in many books. I won't go into what they are, but that's kind of what they are. So you can find those out. Because normally we do the standard deviation as a sample. All right, one thing I do want to mention is this n minus 1. There's many reasons why it's n minus 1. One is that this, by dividing by a slightly smaller number, you get a slightly bigger standard deviation, which actually estimates the population standard deviation better. So that's one reason we do that. The other reason is that this column has to add to 0. So because it has to add to 0, I don't have any freedom for this last number here. So this last number had to be 7 or I wouldn't have gotten 0 here. So this number had to be 82. So I don't have 9 data values really. I really have 8 that have freedom of choice. The last one had to be chosen for me, basically. Not really, but basically. All right. I do want to mention, before we leave this, that you can do this on your calculator. So let me show you how to do this on your calculator, which actually we already did. So I don't know if you realize this, but we already actually did this. So I'm going to go in to hit the stat button again. If you haven't done this already, you're going to put your data in. We put the data in with a 20 so that you can see we get the exact same value. I'm going to go down, edit this column, and I'm going to delete that 20. So I just hit the DEL button. That will delete that 20. Then I'm going to quit this, go back to the stat menu, move over to the word calculate, pick the one var stats. Again, tell it L1 unless you have the newer software, and then it'll already say that, and hit enter. And again, it gave me my mean of 75, which we knew already, but there is my standard deviation. Whoops, right there. Do be careful, it gives you sigma along with S. And the reason it gives you sigma along with S is because it doesn't know if you have a sample or a population. So it gives you both. They're calculated ever so slightly different. So it gives you both, and you have to decide which one you want. You want S because you had a sample. Notice this 13.2 was the same thing we got when we calculated with the formula. This is a little bit faster than the formula. So you're more than welcome to use that. All right, so now we'll talk about another thing we'll look at. So another measure of kind of variability is your percentiles. If you took the SAT test, you probably saw your score in like a percentile, like let's say you're in the 81st percentile. And we want to know what that means. And the 81st percentile means that 81% of the scores were at or below your score, which means 19% of the scores were above your score. So you did pretty good if you had that being the case. You don't know whether or not you passed the SAT based on that. You just know you did better than 81% of the students, or the same as them. There are very specific percentiles that are of interest to us. They're called the quartiles. There are 4 quarters in 100, so every 25%. So 25 would be the first quartile. 25 plus 25 is 50, would be the second. 25 more would be the third, would be Q3, and then the last one would be your maximum. So we get what we can actually think of our lowest value being down here, and that's our minimum. So we get kind of what we call a 5-number summary. You start with your minimum, then you have your Q1, which is the first quartile or your 25th percentile. Q2, which is your second quartile, which is the 50th percentile, also happens to be your median, by the way. Q3 is the third quartile, the 75th percentile, and then your maximum. So you write all 5 of those numbers down, you get your 5-number summary. You can also plot this with what we call Boxplot, and it kind of is a way to put this 5-number summary on a number line. So we'll show you how to do that here in a second. So let's go back to our test scores. So the very first thing you do is find your median. So make sure your numbers are again in order from lowest to highest. You're going to find your median. It was right here at the 73. You don't include your median. If your median had been here in between, you would just think of drawing that line there. But because your 73 was right here, you don't include that. And then to find your Q1, you find the median of these numbers down here. So the median of those would be somewhere between 63 and 71. Add those together, and that'll tell you Q1. Q3 is the median of the numbers above the median. Again, you don't include that median value. That's why that vertical line's there, to kind of remind you that. And then you move yourself in so you get to the middle values. Then Q3 falls between 82 and 90. Add those together, divide by 2, and that tells you what Q3 is. And then you can write your 5-number summary. A mistake I see a lot is that you just write the 5 numbers assuming your reader knows what they are. Don't assume your reader knows what they are. Label them. Your minimum was 50. Your Q1 is 62. Your Q2 was 73. Your Q3 is 86. And your maximum was 92. These are percentages because they're test scores, which are given as percentages. If they were heights, then these units would not be percentages, they'd be inches or centimeters or whatever you measured your height in. So these are not percentages because there's something special about percentages. It's percentages because those are your units. To draw a box plot, you actually just draw a number line. On your number line, let's say we go 50, 60, 70, 80, 90, 100, set some scale up. Then your median, or Q2, is right in the middle. So you draw a vertical line for that median. Q1, find where that is on your scale. It's at 62. Draw a vertical line there. Q3 is at 86. Again, draw a vertical line there. And then you kind of draw a box for these 3 numbers. And then your min is here at 50. Your max is here at 92. And you just kind of draw a line out here from your box to those min and max. Sometimes this is it's called a box plot, but sometimes it's called a box and whisker plot. This is the box, and these are your whiskers. Again, you would put a label on the axis. Test scores, the units were percentages. Notice it's slightly skewed to the left because we have this low value here where everything else is up here. There is something called an interquartile range. IQR, and it's just Q3 minus Q1. So you just take 86 minus 62, gives you your 19%. Again, these are percentages because those are the units. I should mention that standard deviation, same thing. Standard deviation is the same units as your variables had, or your data had. You can find the 5-number summary on your calculator. So let me just show you how to do that. Again, you put your data in by hitting the Stat button. Put your data in L1 using the Edit. We already have our data in there. Second quit. And then you hit the Stat button. I might have made an error there, so I'm just going to check. I did. I made an error here. I accidentally hit an enter there. So this should have been 50. So I'll put that value back in. Okay. And then hit Stat. Move over to the word Calculate. We've done this before. One var stats, puts it on the main screen. Second L1, second number 1 gives you L1. Hit enter. And I know we've seen this before, but if you hadn't noticed, again, that arrow down there, min is 50, Q1 is 63, median is 72.5, Q3 is 82, and max is 92. I think my values are slightly off because I think I had another data value that was messed up. So that's probably why they're not exactly the same, because I accidentally did something, deleted a value, but it basically works the same way. Okay? And that's all you have to do to find it on your calculator.